And now we're ready to go. Okay. So that's the new lesson, but what do you need to ask about? Okay, I don't know what that is.
Is that a timer for the class?
Oh, that's my timer. Thank you. Okay, thank you for, gosh, too early in the morning, I can't even figure out what my buzzer is doing. All right. So anyway, questions about the 3-1 assignment, a very important assignment where you had to do these full-blown derivatives. I was just going through number 37 with Travis, but and not all of you got a chance to see that. But what would you like to ask about on the 3-1 assignment? Could you put number 37 on the screen again? Yes. Okay. So here it is. Let's see. Let's make it a little bit bigger, and then I'll scroll down. So here was the problem that was presented. You don't know about that 1-1. So let me show this. Okay, you were given this function up at the top, and you were supposed to make. So we're supposed to find the line that's tangent to this graph. Therefore, we need a derivative, and is parallel to this line on the right. So that was a little different. Instead of them giving us a point, they gave us something that's parallel to that line. So the first thing I did is, let's solve the equation for y. And now I could see that the slope of the line they want us to be parallel to is -1/2. Y equals -1/2 x plus 3. Okay, so let's keep that in the background. So when we get our tangent, after we do our algebra for this, we're going to set it equal to that -1/2. So that's the overall strategy. As far as how do you actually find the derivatives, so that's what I'm showing here. Okay, so we got to, of course, find the limit of the difference quotient. I had to use f of x plus, so the problem is in blue, f of x plus h minus f of x all over h, the limit as h approaches 0. It's a real mess. I got to get a common denominator. You can see in red, I was working on that. So the left fraction, I multiplied top and bottom by square root x. The right fraction, top and bottom, by square root x plus h. Okay. So that gave me this common denominator of square root x times square root x plus h. And on the left, square root of x times 1 is square root of x. On the right, -1 times the square root of x plus h is negative square root of x plus h. And right away, I did, you're dividing by h over 1, so I right away multiplied by 1 over h. So are we okay up to there? Any questions to that point? Okay, now we got this, we still can't cancel h's. And so what we've got to do is get rid of that root on the top. And the only way to do that is with conjugates. So this step right here, we're multiplying by the conjugate of the top, square root of x plus square root of x plus h. So top and bottom. Okay, so we get the difference of two squares on the top. The square of square root of x is x. The square of that other square root, no square root. And you can see that on the top, what happens? X minus x is gone, and you still have a subtracted h. So I know it's canceled, but right here, where that h is, now I can finally cancel with the h that's been sitting on the bottom. And now I can actually take the limit, because you can substitute in a 0 for h. Square root of x times square root of x is x. And square root of x plus the square root of x is 2 times the square root of x. So let me use my... So basically... So basically, your derivative... There's the derivative right there. Negative 1 over x times 2 times the square root of x. And now is where I pull in that thing from up above. The slope that we wanted this to be equal to is negative 1/2. And then to go down here, what I did is I just used cross multiplication. Negative 1 times 2. Well, yeah. I multiplied both sides by negative 1, then I cross multiplied, and you come up with x being 1. So this is kind of a weird way of them giving us the point. The point they wanted us to do this at was x equals 1. Now we could go back here and take our derivative, and what's f prime at 1? So you plug in a 1 and you get negative 1/2. Okay, now we know the slope of our line, negative 1/2. So get rid of the pictures here. Hang on. Yeah. So now I knew it was negative 1/2, and then of course you can do your slope-intercept thing. By the way, if x is 1, what is y? You still have to figure that out. Okay, so if you go to the top, if you plug in a 1 for this, you can find out that the y-coordinate is actually 1. So finally we know the point. So now we can go back to the bottom and using the point, plug in 1 for y, 1 for x, you can solve for b. Final answer. So that became a fairly involved, kind of a long problem. I don't know. Hopefully you made some sense out of that, Maria. I was trying to, it's kind of a long problem and tried to get it into a manageable amount of time, but maybe I rushed it. I don't know. Okay. Other questions on 3-1 assignment, the 3-1 assignment? Okay. Here's our new lesson, and this is mostly joy today because we're going to get past these the full-blown, long, drawn-out derivatives. I have a question. 29, please. Okay, just got it. 29. All right. So we'll take a look at 29. So here we go, 29. So I think I've got enough shown here. So 29 was the square root of x, the function, and we were supposed to find what? The equation of the line that goes through the point 1, 1. Okay. So I need to, first of all, find f of x plus h. Did we do this one already? Well, anyway, here we go. So you take f of x plus h minus f of x all over h, and then we're going to eventually do the limit as h approaches 0. I need to do a conjugate on the top because otherwise I can't get h to cancel. So I multiplied top and bottom by square root x plus h plus square root x. On top, you get the first square, x plus h, minus the second square, x. X's cancel out. You just get an h on the top. And now you can cancel the h's and you can take the limit. Derivative is sitting right here. Okay, so now what's the derivative at 1? Plug in 1, you get 1/2. And once you know 1/2 is the slope, you can solve for b. Final answer, 1/2 x plus 1/2. So that was for Alexandra. All right. Anyone else? Questions on the 3-1 assignment? Okay. So like I said, good news. While it's incredibly important that you can do that kind of a derivative that we had for today, that's really important. Okay, if you don't get that fully, we've got to get that straight. I guarantee you that will be on the test. So going beyond that now, today we're going to learn shortcuts, so you don't have to do that long process for many of your derivatives. Okay, so it's really cool. You can see some of the things coming up here underneath the outline here. These are all shortcuts. So let's get to the first of those. And the first one is called the constant rule. Whenever you take the derivative of a constant, it's 0. That's pretty simple. So if I give you the function f of x equals 9, what's its derivative? 0. So here, let's do these examples down here. If the function is y equals 7, its derivative is 0. If it's f of x equals 0, the derivative 0. Why? Because 0 is a constant. If it's s of t equals -3, the derivative is 0 because -3 is a constant. And so look at D. Y equals k pi squared. So k is a constant, as you can see. Pi is certainly a constant. A constant times a constant is a constant. And the derivative is, no big shock, 0. So that's wonderful. Anytime you have a 0 as a function, you can take its derivative is going to be 0. If you have a constant as a function, derivative is 0. Okay. One of my all-time favorites, the power rule. And the power rule says if you've got something to a power, x to a power, I know most of you know these shortcuts already. Here, let's look at the example right down here, part A. If you have x cubed, take the power 3, bring it out in front, multiply by it, and reduce the power by 1. Derivative of x cubed, 3x squared. So bring that 3, multiply the entire thing by that, and reduce the power by 1. Okay, now this gets a little bit messier when you have something like a cube root. Can you write the cube root of x as a power? Yeah, it's x to the 1/3 power. Okay, how do you take the derivative of x to the 1/3 power? Bring that power 1/3 out in front, multiply, and reduce the power by 1. What's 1/3 minus 1? -2/3. So result 1/3 times x to the -2/3. And then interpret that back. What does x to the -2/3 power mean? What does a negative exponent mean? Oh, it means 1 over that thing, that x to the +2/3. So usually this is how we will end up. So did you follow that? Turn it into a first turn it into a normal exponent without a root. X to the 1/3 is the same as the cube root of x. Now follow the power rule. Bring that power out in front, multiply by it. And now take the power that you had and reduce it by 1. And then just turn that negative exponent into a positive 1. That means put it down in the denominator to the positive power. Here, let's do part C. 1 over x squared. Can you write that as x to a power? Yeah, that's x to the -2. Derivative, bring the -2 out in front, multiply by it, reduce the power by 1. -2, when you reduce it by 1, goes to -3. Get that negative exponent out of the answer. That just means move x down to the denominator and make it a positive power. So, in summary, you can see at the very bottom there. So first you need to rewrite a function sometimes just to get it into x to a power. And then go ahead and follow your rules. And if you have to, when you're all done, you don't want to leave a negative exponent in your problem. Make it a positive by moving it to the opposite, from numerator to denominator or from denominator to numerator. Okay. So where were we here? We're on the power rule. Okay. Now, the constant multiple rule. So you already know the derivative is a constant is 0. But what if you have a constant out in front of a function? Like c out in front of f of x. And you notice what it says? It basically says ignore it. Just leave it there. C. Don't do anything. And then just take the derivative of the function. So with a constant, you pretty much just let it be when it's a multiplication, a constant out in front. So let's look at the examples. Part A, derivative of 5 over 2x cubed. Well, 5/2, just let that be. What's x cubed in the denominator? Oh, that's just x to the -3. What's the power rule? Bring the -3 down, multiply, and then take the power and reduce it by 1. -3 goes to -4. And then just put it together. What's 5/2 times -3? -15/2. Why is x to the 4 on the bottom? To make it positive. Was somebody trying to ask a question? I heard something. I want to make sure I'm not ignoring you. Did anyone ask a question? Do you guys get what I just did with A? Can you see the progression here from left to right on part A?
Yeah.
Okay, thank you. Let's look at part B. Y equals 5 over, oh, watch out, 2x parentheses to the third. That means I not only have x to the third, I also have 2 to the third, right? So there, that really winds up being 5 over 8. And x is downstairs, so it's x to the -3. Now go ahead and follow the power rule. -3 multiplied by the whole thing out in front, reduce power by 1. I know you know the rule. What I'm worried about is, do you see how they got to this last thing here? Sorry, I'm having trouble with my technology here. Do all of you see how we got there? 5 times -3 is -15. The 8's still on the bottom. And then because we had an x to the negative power, we had to make it positive by moving it to the bottom. There's a bunch of things going on there. Okay, how about C? 7 over 3 x to the -2. Well, isn't that, hey, I can change that x to the -2, just move it to the top and make it x to the +2. Okay, let 7/3 be. Don't do anything with that. Now use the power rule on x squared. Bring the 2 down, multiply, reduce the power by 1. So instead of x squared, it becomes x. And then just bring it all together. Bring it all together here. 7 times 2x is 14x over 3. Look at the last one, the one that I wrote in. F of x equals 9x to the 4th. Let the constant be 9. Don't do anything with that. Power rule. 4, bring it down, multiply. Reduce power by 1. Simplify. The power rule is awesome. And the constant multiple rule is really simple to work with, because with a constant out in front, you don't really have to do anything with the constant. Okay. So now we got some memory work again. 2 derivatives you're going to have to memorize. And they are the derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. So those you're going to want to tuck away. It's like kind of like you had to learn those special limits for sine and cosine. You need to learn these derivatives. So let's take a look at example regarding that. So part A, how do we take the derivative of 2 sine x? What do you do with the constant? Nothing. Just leave the 2 there. What's the derivative of the sine? Oh, we just learned that's the cosine. Oh, okay. 2 cosine. I should have brought this down a little lower because a reminder of those 2 new derivatives up there. Part B, if our function is sine x over 2, well, let's simplify that. Isn't that the same as 1/2 sine x? Yep. And when you take the derivative of a constant, just let it be 1/2. What's the derivative of the sine? The cosine. And so the final derivative is 1/2 cosine, which, by the way, could be written as cosine x over 2. Let's go down to part D. Function cosine x minus pi over 3 sine x. So we got 2 parts here. Just take the derivative of each part. So first, what's the derivative of the cosine? Look up here. Oh yeah, minus the sine of x. Second part, what's the derivative of negative pi over 3 times sine x? Just let the constant be. That's a constant, right? Pi is a constant, 3. And 3 is, pi over 3 is a constant. And what's the derivative of the sine? The cosine. I'm going to pause. I'm doing a lot of talking. Is everybody with that? I'm always trying to keep my eyes open and look. Do I still have a question here? Okay, I think we're set. All right. So now comes maybe the most joyous one of all. The derivative of e to the x power. Yeah, what can I say except praise the Lord? It's its own derivative. This is the final nail in the coffin why e to the x is so special mathematically. It's its own derivative. The derivative of e to the x is e to the x. Awesome. So, all right, so let's apply that. So let's take this one, 3e to the x. Well, what do you do with a constant? Nothing. So you just let 3 there. And what's the derivative of e to the x? 3 to the x. So what's the derivative of 3e to the x? 3e to the x. So you just break it in. Okay, how about this one? What's the derivative of x squared? Oh, I'm sorry. Here we are. We're right here. X squared plus e to the x. Well, what's the derivative of x squared? Power rule, 2x. What's the derivative of e to the x? E to the x. Answer, 2x plus e to the x. And finally, part C, sine x minus e to the x. What's the derivative of the sine? Cosine. Okay. And what's the derivative of e to the x? E to the x. Answer, the derivative is cosine x minus e to the x. So this is what? The most joyful function of all for a calculus student? E to the x. Its derivative is itself. I know it's kind of let's see. It's kind of like what's the additive inverse of 0? What do you have to add to 0 to get a 0? And it's itself. It's 0. So it's very nice. So let's take some examples from the assignment now. Number 8, you can see the directions right there. Use the rules of differentiation. So we have 3 over x to the 7th. First, rewrite that. Put the 3 out in front. And really, 1 over x to the 7th is x to the negative 7th. Now we're perfectly set up to do the power rule. Negative 7, multiply that by what you had. Negative 7 times 3 is negative 21. Now take the power and make it 1 lower, x to the negative 8th. And then get the negative exponent out of there, rewrite it. Final answer, negative 21 over x to the 8th. So our book, this is, by the way, the general, the rule for our book is they don't want you to leave negative exponents in your final answer. So when you arrive at a place like this, you want to rewrite it with x being to a positive power. All right? So here's a couple. In the section, you want to rewrite a function before. So again, you need to do something with it before you get started. So here's number 28. Pi over 3x quantity squared. So the first thing I have to do is I got to square those parentheses. So now I have pi over 9x squared. Still, how do I get that ready to differentiate? Well, pull the pi over 9, which is the constant part, off to the side, and then write the power. We don't want that in the denominator, so write it as x to the negative 2. Now, all I have to do is do a power rule. Take that negative 2, multiply it by the constant, lower the power by 1, and then finish it up by making the exponent positive again. 29, what do you do with a root? Write it as a power. So square root of x over x is x to the 1/2 over x. How did I get that to be equal to x to the negative 1/2? Somebody respond to that, please. How did I go from x to the 1/2 over x to the x equals x to the negative 1/2? Somebody, please.
Because the bottom is a 1. So then when you do like half minus 1, it'd be negative half.
Exactly. Thank you. That is correct. So here's our function. Now can you take the derivative? Sure. Power rule, bring that negative 1/2 out in front. And then take the power and reduce it by 1. You got to be careful with your negatives here. Negative 1/2 down 1 is negative 1.5 or negative 3/2. And then, not so super easy. You got to get that power to be positive again. So x goes downstairs to the positive 3/2. And, you can just, I suppose we could have written that as negative 1/2 times 1 over x to the 3/2, but kind of silly not to bring those two fractions together. Any questions? Okay, so now that's it. The rules are pretty simple, and we move to a different topic here. I wouldn't say different topic, but as you know, we've been dealing with slope all along, right? Because what's a difference quotient? Nothing. It's just a slope formula. Y2 minus Y1 over X2 minus X1 is where it all came from. So what's important for you to realize is there are two types of rate of change. One is called average rate of change. And that is nothing more than slope. That's all. What we're doing with the derivative is we're finding instantaneous rate of change. So in other words, with a derivative, you've got the formula for the slope at any point. Average rate of change just takes 2 points and does the slope formula. Instantaneous rate of change finds, when you find the derivative, you've got the formula for the slope at any value of x. Okay. You know, here's an example of a problem we'll just take a look at here, okay? So we've got a ball dropping, and I gotta get this a little bit bigger for you. Sorry. So we got a ball dropping, and here's its equation right here. By the way, that negative 16 is simply, yeah, I guess we don't need to look at the picture, so I can make it bigger. Negative 16 is simply in meters per second. It's the value of gravity. Why is it negative? Because gravity is pulling downward. So a ball is dropped from a height of 100 feet. The ball's height in time is S equals negative 16 t squared plus 100, where S is measured in feet and t is in seconds. Okay, that's feet per second, sorry. What's the average velocity over each of these time intervals? So A is saying from x equals 1 to x equals 2. That's an interval, not an ordered pair. Notice the square brackets there. So at 1, what's its height? So what is S of 1? Turns out to be 84. So after 1 second, that's how far the ball, that's the height of the ball. Remember, it was dropped from 100. Okay, so we have the point, basically 1 comma, I got to get my pen working again. This mouse just doesn't do it. Hang on. So let's go back here. Let's erase that mark I just made. Now let's go back and grab the pen. My pen needs to be awakened. Why? Sorry about the delay. Hang on. So for those Nintendo fans, I got to blow on it, kind of like you have to blow on. You used to have to blow on a cartridge.
I remember.
Yeah. Okay, finally, all right, we got a pen. So we just found the point when t is 1. When 1 second, it's going to be at, except I wrote the number wrong. It's 84. Wow, dyslexia. Okay, and what is it at 2? So when you plug in 2, you can see they did it right here. See, the answer is 36. So what you have here is just 2 ordered pairs, 184 and 236. What's the slope? Y2 minus Y1 over X2 minus X1. See, they did it right here. And what's the answer? So over that first second, that's from second 1 to second 2, that's the rate. That's the average rate of change. Okay, let's just do one more. Then it asks you to do it from 1 to 1.5. Okay, so if you plug in a 1, we already did that. That's 84. And if you plug in 1.5, you get 64. So now you've got these two ordered pairs. How do you find the average rate of change? Find the slope. They did that right here. So for that time period, from second 1 to second 1.5, the average rate of change was negative 40 feet per second. So whenever you're asked to find average velocity, you are just basically talking the slope between 2 points. Okay. If they ask you for the exact rate of change, well, now you're just going to use the derivative. All right, so we'll get back to that a little bit later. Okay. I think we've already looked at that one. And we've looked at those. So let's just take a look at 32. Finding the slope of a graph. So in this section, find the slope of the graph of the function at the given point. This is old stuff, kind of, but let's just do it. Except notice today you don't have to do the long derivative. Praise the Lord, right? So here's our function. Would you agree with this rewriting? So if you did 2 minus 4 over t, isn't that the same as 2 minus 4t to the negative 1 power? Yeah, it's just rewriting it. Now, take its derivative. Take the exponent, negative 4. I'm sorry, negative 1. Bring it out in front. I'm not supposed to have done anything with a constant. Oh, yeah, what's the derivative of a constant? 2. That's 0, so that's gone. That's really a 0 plus. Negative 1 times negative 4 is plus 4. Reduce power by 1, negative 2. Rewrite. 4 over t squared. Now, they asked to find the slope of the graph at 4, comma 1. So now, what's f prime at 4? Just plug in a 4 in place of t. You get 4 over 16, which simplifies to 1/4. So the slope of the graph at that point is exactly 1/4. Here's another one from that same section. This is an e to the x one, so this is going to be nice. Okay, so right off the bat, what's the derivative of e to the x? E to the x. What do you do with a constant? Ignore it. This thing is, it's its own derivative. Negative 4 e to the x. That's our derivative. Now, what's the derivative at 1? Plug in a 1 for x. E to the 1 is e. There's our derivative. That's the slope of the graph. Number 44. Okay, so what do we do with this thing? I know I showed you the answer already, but algebra rewriting is very important. So when a whole numerator is divided by x, isn't that the same as dividing each term on top by x? So that's what I'm trying to show in this step right here. In this step right here, I'm just showing, all right, divide each term by x. All right, so the first term, what's 4x cubed over x? Well, that's 4x squared. What's 2x over x? That's 2. Uh-oh, what's 5 over x? Well, I don't know, but I can rewrite it as 5x to the negative 1 power. All right, now let's take the derivative. What's the derivative of 4x squared? Power rule. 8x. What's the derivative of a constant? Gone. And what's the derivative of this 5x to the negative 1? Power rule. Negative 1 brought down, reduce power by 1. And then get rid of that negative exponent. Again, I'm going to take a little pause. Sometimes yeah. Does anyone have a comment or a question? Right, number 50, another example. Here it just says find the derivative, the directions. Okay? Well, we got to rewrite things because we're not in friendly format. 2 over the cube root of x. Does everybody see that that's just 2x to the negative 1/3 power? Algebra knowledge. Okay. Now what's the derivative? Power rule. Negative 1/3 times 2 is negative 2/3. Reduce the power by 1. Negative 1/3 minus 1 is negative 1 1/3, negative 4/3. What's the derivative of the cosine? Minus the sine. Ignore the constant, negative 3 sine. That's basically it. Then just getting the exponent to be positive brings me to the final. That's as good as we're going to do for a derivative. Okay, let's take a look at 54. So what are the directions here? Find an equation of a tangent line to the graph at the given point. Then it encourages you to use a graphing utility. Okay, so here's our function. 2 over the 4th root of x cubed. Got to rewrite that as 2x to the negative 3/4 power. Now take its actually a very easy derivative. Power rule, negative 3/4 times 2. Right? The 2 cancels into the 4 and we get negative 3/2. Reduce the power by 1. Negative 3/4. Negative 1 3/4 when you reduce it by 1, and that can be written as negative 1 3/4 is negative 7/4. Okay? Now, we could rewrite it, but we don't need to, because now the big question is, what's the derivative? So we found the general derivative. What's the derivative when at 1? So you plug in a 1 here. 1 to any power is 1. Negative 3/2 times 1 is negative. So there's our derivative at 1. Okay, so if that's your slope, you know how to do all of this. You can actually get the equation of the line. Let's take a look at that one in Desmos. Okay, now I gotta try to keep track of this. So we got 2x to the negative 3/4 power, and the point is 1, 2, and y equals negative 3/2 x plus 7/2. Let's see how that looks. So first we have 2 times x negative 3/4 power. Okay, so there is our function. The point 1, 2 is right there. So there's our point. Now we calculated the tangent line to be negative 3/2 x plus 7. And you see how, yep, we found the equation of the tangent line. There it is, going right through the point 1, 2. So that's what they would like you to verify these, using Desmos or using your graphing calculator. That's what's going on there. All right. Let's take a look at 94. 94 relates to that average rate of change and instantaneous rate of change that we talked about earlier. What's an average rate of change? Take 2 points and find the slope. What's an instantaneous rate of change? The derivative at that point. So here we go. The function is t squared minus 7. All right. What's the average rate of change over this interval over here on the right, from 3 to 3.1? So we got to first find those. What's f of 3? Plug in 9 minus 7 is 2. So there's our first point, 3, 2. What's f of 3.1? Turns out to be 2.61. So we have 2 ordered pairs. Average rate of change is just slope. And as you know, it doesn't matter which point you call 1 and which one you call 2, as long as you don't change your mind halfway through. What's the slope? 6.1. Okay, so there's the answer to the average rate of change. All right. Then it says, what's the instantaneous rate of change at the endpoint? So first, we got to find the derivative. Easy derivative, right? T squared minus 7 is 2t, right? Because power rule, 2t for the 1, constant, nothing. All right, what's f prime at 3? So plug in a 3 into your derivative formula. It's 6. What's f prime at 3.1? 6.2. So you see how, all right, so the exact rate of change at 3 is 6. The exact rate of change at 3.1 is 6.2. And the average rate of change is right between them, isn't it? That makes sense. That won't always be the case because they won't always pick the midpoint like that. But so average rate of change, you just have 2 ordered pairs and you're going to find the slope. That's it. Instantaneous rate of change, use your derivative, and then use your derivative at the point. Now let's just take a look at one more example of this. So this time the function, let's say the function is x squared up at the top. What's the average rate of change over the interval from 1 to 3? What are the 2 ordered pairs? Well, what's f of x? What's f of 1? 1 squared is 1. So we got the point 1, 1. And what's f of 3? 3 squared is 9. What's the slope? You see I have it up here. It turns out to be 4. So the average rate of change is 4. Part B, what's the exact rate of change at the endpoints of the same interval? What's the derivative of x squared? 2x, right? Power rule. What's the derivative at 1? 2. The derivative at 3. 6. So here are your exact rate of changes at the end. And again, the average makes sense. The average of 6 and 2 is 4. Okay, well, core exercises for 3-2 are as follows. You can get that from the website, so you don't have to copy it right here, but questions? Anything you want to bring up? All right. Thank you very much for coming. Let me know if you have some questions. You can contact me, of course, by phone, by text message, by email. Any of those will work. Have a good one.